500 million years ago, Earth was a radically different planet. The continents were still bare, devoid of trees or grass. There were no flowers swaying in the wind, no birds flying across the sky. The surface was dominated by bare rocks, arid deserts, and active volcanic regions. And yet, amid this seemingly inhospitable landscape, the waters that covered much of the globe teemed with life. In the seas of this primitive world, evolution began experimenting with ever bolder combinations. Before this period, life was simple and modest: microorganisms, spongy colonies, a few gelatinous forms drifting on ocean currents. But then, something extraordinary happened: a sudden leap in the complexity and diversity of life, an event scientists call the Cambrian explosion. It was on this stage that the planet's first superpredator emerged, a creature so efficient at killing that it forced all others to change or disappear. Much later, it would receive a strange name, Anomalocaris, meaning anomalous shrimp. The name came from fragmented fossils, confusing researchers for decades. In the 19th century, fragments of its claws were described as independent animals, and its circular, toothed mouth was identified as a fossilized jellyfish. Only in the late 20th century did scientists realize it was all part of a single animal. And what an animal! At about 1 meter long, Anomalocaris doesn't seem all that threatening by today's standards. But back then, it was gigantic. Most Cambrian creatures were just a few centimeters, often millimeters, long. Compared to it, trilobites, those convex-shelled arthropods so common in the fossil record, looked like toys. And being small, slow, and fragile in an ocean where Anomalocaris swam rarely ended well. Its body was divided into flexible segments, allowing it to undulate laterally like a modern fish. This ability made it fast and unpredictable, an active hunter capable of chasing and dodging at the last moment. Just ahead, 2 long, articulated appendages, curved toward the center, functioned like living sickles. Each of these claws was equipped with spines that grabbed, cut, and pulled the victim without any chance of escape. In the center of the body, just below the head, was its most disturbing feature: a disc-shaped mouth, armed with rows of serrated plates that crushed and shredded anything that entered. But perhaps most frightening were its eyes. Each measured about 3 centimeters, enormous for the period, and was composed of thousands of individual lenses. With these, Anomalocaris could form detailed images, detect movement quickly, and hunt even in low light. In a shallow ocean, this meant nothing went unnoticed. Upon spotting prey, it would begin a silent chase until, with a swift swipe, its claws closed and the victim disappeared. This active hunting behavior was relatively new in the history of life. Until then, many predators were more opportunistic. They waited for prey to pass by or fed on scraps. Anomalocaris brought a new ecological pressure. It stalked, planned, and attacked, and that changed everything. In the millions of years following their rise, many prey animals began to develop defenses. Trilobites emerged with thicker shells. Some animals adopted burrowing behaviors, quickly burying themselves in the sand. Others assumed forms that mimicked the seabed in an attempt to camouflage themselves. This arms race, where each adaptation in the prey led to a counter-adaptation in the predator, would become one of the most powerful drivers of evolution, and Anomalocaris was in many ways the trigger for this dynamic in the animal kingdom. But the reign of any creature, no matter how formidable, is rarely eternal. Sudden changes in climate and ocean currents began to alter the distribution of marine ecosystems. Previously warm, shallow areas cooled, harming species that depended on these conditions for hunting. Small organisms began to explore new niches and diversify. And slowly, other predators began to emerge. Among these new competitors were primitive forms of aquatic vertebrates, ancestors of fish that would later become masters of the seas. These early vertebrates possessed cartilaginous structures, more complex mouths, and hydrodynamic bodies. Although smaller than Anomalocaris, they were agile and had different hunting strategies. The absolute supremacy of the strange shrimp was beginning to be challenged. Furthermore, the very basis of their diet was changing. Trilobites, their primary targets, were no longer as vulnerable. With stronger armor and improved reflexes, they became more difficult prey. In some cases, even potentially dangerous to an unprepared predator. Natural selection, which had previously favored a giant, specialized body, now began to favor adaptability, dietary variety, and a reduced reliance on a single prey type. With so many simultaneous pressures, Anomalocaris populations began to decline. Geologically speaking, this happened rapidly. Millions of years, a mere instant for the planetan, the Cambrian's largest predator, disappeared. But his legacy didn't die with him. On the contrary, he left profound marks that would echo for hundreds of millions of years. The evolutionary pressures he imposed on his prey shaped the anatomy and behavior of countless species. Stronger protective structures, sharper senses, faster escape behaviors, all of this was, in part, a response to a multi-million-dollar game of cat and mouse that began with him. Marine predators that emerged much later followed similar patterns: elongated, flexible bodies, keen senses, and quick, precise attacks. Sharks, squid, and swordfish all descend, indirectly, from an evolutionary path paved by early superpredators like Anomalocaris. This creature also holds a special place in paleontology for another reason. It represents a moment when life experienced a new complexity. For the first time, a predator emerged that not only survived on what was available, but actively shaped the world around it. This places Anomalocaris as a true landmark in the long history of terrestrial life. Today, when we look at the fossil record, we can reconstruct their shape, imagine their movements, and even speculate about their behavior based on comparative anatomy. But even with all the accumulated knowledge, there's something hypnotic about this prehistoric ghost. Perhaps it's the idea that, at the beginning of it all, when the game of life was still new, there were already monsters of flesh and exoskeleton who knew the rules, but only played to win. And there's another detail: every time a dominant predator disappears, a vacuum appears in the ecosystem. Nature hates a vacuum. When the Cambrian Ocean's throne was empty, other creatures emerged to fill its space. Some would be even larger, others even more lethal. Some would develop teeth capable of tearing prey apart in a single blow, others venoms to kill effortlessly. With each cycle, life would become more complex, more dramatic, and in some ways, more dangerous. The end of Anomalocaris was not, therefore, the end of its history. It was the beginning of a spiritual lineage of predators that would reach from the Devonian seas to the present-day oceans. Its initial reign paved the way for the evolution of creatures as formidable as sea scorpions, placoderm fish, and much later, modern sharks themselves. They all follow the lesson left by that first king: to be master of the sea. It is not enough to be great. You must change the world around you. The ocean, of course, has never been without a legendary monster for long. And the next ruler to emerge from the waters was so incredibly dangerous that, if it could appear before us today, it would freeze the blood of even the most fearless divers. With jaws lined with razor-sharp rows and a body designed for lightning-fast ambushes, it reinvented the art of sea hunting. But that is a story for another chapter. The Cambrian world was a veritable laboratory for life's experiments. To understand how Anomalocaris became the first superpredator, we must examine the landscape and rules of this primitive planet. At that time, Earth's atmosphere still contained significantly lower levels of oxygen than it does today. This factor limited the size and speed of many creatures. But in the shallow oceans where light penetrated easily and the photosynthesis of microscopic algae released more oxygen, it was possible for animals to reach dimensions never before seen at that stage in life as history. The seashores were covered in bacterial mats and entire communities of filter-feeding organisms. Tiny worms and primitive mollusks burrowed into sediments. In the waters above, trilobites roamed in search of food, sometimes forming large clusters. There were also bizarre creatures that seemed to have sprung from the imagination: Opabinia, with its unexpected proboscis, Hallucigenia, with dorsal spines, and Wiwaxius covered in protective plates. It was a biological carnival of shapes, colors, and survival strategies. In this scenario, Anomalocaris occupied a unique position. Its size alone was intimidating, but more than frightening, it could act in ways no other creature of the time could. Its ability to swim actively wasn't just a speed advantage. It meant it could explore vast hunting grounds, moving from reef to reef, from seafloor to seafloor, inevitably finding abundant meals. Unlike ambush predators, it didn't rely on chance. It created opportunities. Modern studies in paleontology and biomechanics suggest that their front claws worked in remarkable synchrony, one closed while the other opened, allowing for rapid captures and sequences of attacks. This coordination would be comparable in modern terms to the synchronized attack of a praying mantis's front legs, except in the case of Anomalocaris. It occurred in a marine environment, with desperate prey attempting to swim or bury themselves before contact. Another fascinating detail is the shape of its mouth. Cylindrical and composed of rigid plates arranged in a circle, it rotated during the biting motion. This meant it could crush hard shells as if it had a living circular saw in the front of its head. This structure, called an oral cone by paleontologists, was revolutionary for the period and places Anomalocaris as a milestone in the evolution of feeding strategies. The impact of this creature on the evolution of its prey was so profound that some experts argue that active predators of this type were a fundamental trigger for the rapid diversification of the Cambrian. This is called predatory selective pressure, when a dominant species forces all others to adapt or go extinct. This escalation creates new variations and eventually new species, accelerating the complexity of life on the planet. For millions of years, Anomalocaris reigned virtually unrivaled. Each generation repeated the cycle of supremacy, patrolling trilobite-rich areas, hunting down defenseless life forms, and driving out smaller competitors. It was the apex predator incarnate, but the history of life is written in change, and evolution is relentless. Small animals began to develop more advanced morphologies: primitive fish with bony frontal plates, organisms with segmented muscles that allowed them rapid bursts of speed, microcrustaceans that swam in schools, confusing solitary predators. At the same time, changes in sea level, sometimes rising, sometimes falling, reshaped the map of habitats. Traditional hunting grounds could disappear in just a few generations. And there was also a silent but lethal factor: water chemistry. Changes in mineral composition and salinity affected the availability of basic foods. In the food chain, small losses in nutritional levels in the lower layers eventually reverberated up to the top, affecting the largest predators. Even their powerful eyes and lethal claws couldn't change that. It's almost poetic to think that the planet's first superpredator, whose body seemed like a perfect weapon shaped by evolution, was slowly defeated not by a single enemy, but by a combination of environmental changes and new, more agile and adaptable competitors. Its size, once its greatest advantage, became a disadvantage when food required more energy to find. And so, in timescales that seem unimaginable to us, but seem like fleeting blinks on Earth, Anomalocaris began to disappear. One species after another vanished from the seas, leaving only their fossils as silent testimony to the reign that once existed. Today, paleontologists study these fossils with technology Darwin himself couldn't have dreamed of. High-resolution CT scans that reveal internal structures, chemical analysis that indicate period pigments, 3D reconstructions that allow simulations of swimming and hunting. Each discovery adds a new piece to the puzzle, showing that, although extinct, Anomalocaris still dominates in some way human fascination with the monsters of the past. And its importance goes beyond ancient marine biology. It's a reminder that evolution works without prior plans, but with surprising results. What worked yesterday may not work tomorrow. Adaptation is the only currency of survival, and those who fail to change disappear no matter how glorious their reign. The throne of the Cambrian Ocean did not remain empty for long. Other kings of the deep would rise: giant sea scorpions, armored placoderms with destructive jaws, marine reptiles that seemed like legends. Each left its mark on history, but all, in some way, followed the path that had been blazed by that first absolute hunter. When you imagine Anomalocaris gliding beneath the blue waves of a Cambrian sea, it's impossible not to marvel at the ingenuity of life. The planet we know today, teeming with forests, cities, and humans, was once ruled by creatures that defy our imagination. And perhaps the greatest lesson left by the world's first king is this: power is never permanent, but influence can last forever. Because while Anomalocaris's body disintegrated hundreds of millions of years ago, its shadow still haunts the oceans. In every lightning attack by a shark, in every silent hunt by a giant squid, there are echoes of that pioneer. Evolution doesn't forget the masters that came before. It simply reinvents them. And so, in an unbroken line that spans eras and extinctions, the legacy of Anomalocaris lives on, fused with the essence of every predator that followed it. It was the beginning, and the beginning, as we know, is where all truly great stories are born. But every beginning sets the stage for what comes next. And in the next chapter of this story, another monster will emerge, larger, more relentless, with teeth as sharp as swords, a ruler of the waters who would make even Anomalocaris look delicate. The next king of the seas was coming, and the earth, once again, would be changed forever. If this story of the first king of the seas impressed you, just imagine what's coming next. In the next chapter, we'll encounter a predator so lethal that even the largest dinosaurs would turn tail and flee. So if you want to continue this journey through the wild history of our planet, leave a like now, subscribe to the channel, and tell us in the comments, which creature do you think inherited the Anomalocaris throne? Your answer could appear in the next video.